computer is slow today. Sort of like me, I guess. Quadratic functions with the same zeros. It's a fascinating chapter because it seems to go back and forth between incredibly difficult lessons and very manageable lessons. So today, very manageable. I mean, it's a big package of paper I've given you, just so you're not madly copying today. But in the end, the big idea will be pretty simple when we're looking for quadratic functions with the same zeros. Okay? Here we go. Up to this point, we have seen quadratic functions in 3 different forms. We have seen quadratic functions in standard form. Standard form, well, I'm oversimplifying the issue, but standard form, generally what you see is no brackets whatsoever. You can easily pick off the A, the B, and the C for the quadratic formula. So this is standard form. Another form we saw was factored form, and usually 2 brackets. Sometimes it only has 1 factor squared like that. So it's not quite as simple as what I'm saying, but factor generally you can see the 2 factors out like that. And then vertex form, 1 occurrence of x. That was the important little qualification there, is that you only see x once there. Okay? Someone says, well, if that -5 wasn't there, or that -2 wasn't there, wouldn't vertex form also be factored form? And that's true. There is some special cases here in all of this. Okay? You got this? All right, there they are. In which of these 3 forms is it easiest to identify the zeros? By far, not even close, no comparison, one of these is way easier to pick off the zeros. Ben? Factored form. It's why we put it in factored form, is so we can easily pick off the zeros. And here, factored form, here it comes. If I wanted to find the zeros of this thing, I just look at it and go, there they are, -3 and -5. It might be the whole reason to factor at this point, is to go, if I want to find the zeros, factored form will easily give me those zeros. Okay? Pretty straightforward lesson so far. Seeing again the 3 different forms of the quadratic, and then seeing that factored form is the one that's easiest to pick off the zeros. Any questions so far? On these lessons that I think are a little bit easier, it's easy for me to rush through them, but I'm not going to do that. I'm going to try very hard not to rush through it, even though we're on a slightly shortened period today.
I'll be back.
We'll use this idea in a moment, so don't forget about it. A little bit of sound effects for you on a Wednesday. So here's my investigation. A parabola has zeros of -2 and 3. How many parabolas can you sketch that have those zeros? And the answer is many. There's an infinite number of parabolas that can have those zeros. Here they come. You don't have to draw them all. My PowerPoint gets completely out of hand. But you can just draw a few to get the idea here. The animation's just jumping along there. But you see all those different color ones. You should draw 3 or 4. Maybe a couple upside down, a couple opening upwards, a couple opening downwards, just to go, yeah, I could draw all sorts of parabolas. I can make them go as high or low as I want. I can vertically stretch them. I can flip them upside down. I can do all sorts of things here. So just having the zeros means there's lots of parabolas. You've narrowed it down to a certain family of parabolas. That's actually the technical word for it. You've narrowed it down to a family of parabolas. They all kind of look same-ish. They all go through those same zeros, but obviously all of those parabolas are very different. You just have to choose a few. You don't have to do that many. Just draw through the zeros, one that goes pretty shallow, then one that goes to pretty deep, and the one that goes really deep, and at least one opening downwards to go, and they can open downwards. So we know a lot about the parabola when we have the zeros, but we don't know everything. We're far from knowing everything about the parabola once we have the zeros. Was that enough time to draw a whole whack of parabolas there? On the next page it gives you, yes, a whole whack of them. So there's infinitely many parabolas with zeros of -2 and 3. You'll never run out of parabolas to draw there. The question we need to answer is, how are the parabolas with the same zero related? Only difficult part in the whole lesson with a shockingly simple answer. Not an easy answer. See the difference in easy and simple? Easy is like, oh yeah, everybody knows that. Simple is like, oh, once I see it, that's only one step I got to do. That's only one thing I have to do. So how are the parabolas with the same zeros related? Let's try to answer the question by thinking about transformations. Let me get rid of that thing. Which transformations don't affect the zeros of the graph? Let's think about that. If we move it left or right, that's going to move the zeros. If we move it up, down, that's going to move the zeros. If we horizontally stretch it or compress it, that's going to change the zeros. There's only one transformation that doesn't do any of those things.
Is it inverse on the x-axis?
Yes, the reflection this way will not do it. Yes, that's right. And with that, there's one more thing you can do to these parabolas and not change their zeros. So the reflection is one, yes? But there's one more thing you could do to these parabolas. So let's look at them again. It's a stretch. Any vertical stretch isn't going to stretch the zeros. And we sort of alluded to that in the previous chapter, these invariant points, but I didn't spend a lot of time on it, really. But if we multiply all the y values by a number, the ones that are 0 aren't going to change because they're already 0. When you multiply them by a number, they don't move. So then we come to our grand conclusion, the only really big moment in the whole lesson. What doesn't affect zeros? Vertical stretches and reflections and vertical reflections. If you want, just multiplying this thing by a number, the zeros will stay the same. So you can always just multiply a quadratic by any number you want. You'll get a new parabola, but at least it'll have the same zeros. So theoretically, we should be able to apply. How much of this do you have to copy down? Let me look. So I know how much time to give you here. You need that too, right? So theoretically, we should be able to, that's the important paragraph. Boy, if you're going to red star something or highlight it, let's see. Writing on PowerPoint is no easy feat, but I will attempt. Yellow highlighter is not going to show up very well. Pointer options. Highlighter, ink color. Let's go with red. I don't know if you'll be able to read it after I do red. So theoretically, we should be able to apply a vertical stretch, vertical compression, or vertical reflection to any parabola and still maintain the same zeros. Okay? That should be allowed. You should be able to do those things. Now, if I've made it so you can't see that now, let me get my eraser out. And for some of you who don't have a fancy highlighter, trying to convince you that a highlighter is a great way to go, but I'll switch over to a pen and I'll just put a nice big red star by that line as the most important paragraph of the whole lesson. But see, very simple. Not easy, but very simple. That just means that I can take a multiplier of parabolas, just multiply the parabola by anything I want, and it'll have the same zeros. Will it be a new parabola? Yeah, it could be a completely different looking parabola, but it'll have the same zeros. Okay. Is that 6 slides already? With 10 more to go. I've got till 12:15 though, so I'm good. I have your quizzes marked. I will return those, along with your tests. I know that's been a long time waiting, but I had to wait on a couple of situations. So all of that coming at you in the last few minutes of class. I didn't give you an updated mark after your quiz, because chances are it didn't move your mark by that much. But if you get your quiz back, and your quiz mark was a lot different than what your last updated mark was, it was very different, then maybe your mark has changed a little bit, and maybe you want to see it, and then you just come and see me. Okay. More time there? Is it okay? More time? Yeah? A lot of talking so far for me to say one thing. If you want to keep the zeros the same, go ahead and multiply the whole thing by any number you want. Positive, negative, doesn't matter. You'll keep the zeros the same. It's good? No, not good. Well, that's all right. Mr. Todd made a mistake this morning and didn't eat anything. So I'm starting to get a little punchy here. Oh! Accidentally pressing the button while I'm opening my snack here. Oh. Oh my. Oh, I didn't understand what the next slide said. It says here, let's try some, shall we? Say I've got this parabola, f at x equals x squared minus 8x plus 12. Using technology, we could easily graph it. I'm going to show it to you in the PowerPoint, but I encourage you, if you haven't downloaded Desmos already, it's a great weapon to have on your phone when you're doing homework to go, what does this thing look like again? And you can just plug it into Desmos. It's also a website, so if you have to on a computer, that's fine too. There's the graph of y equals x squared minus 8x plus 12. I'm just showing it with technology. Should you be able to complete the square to find the vertex of this thing? Yes. The quiz proved that's not true for everybody. However, I'm not doing that in the lesson here. In the lesson, I'm trying to focus on the idea of today's lesson. Once I graph this parabola using complete the square to find the vertex, if I apply a stretch factor of 2, you ready for me to apply stretch factor 2? I'm just going to multiply everything by 2. Simple. I didn't say it's easy. It's not necessarily easy to understand, but simple what I'm going to do. I'm just going to multiply the whole thing by 2. I'm literally taking 2 times the whole function. I'm vertically stretching it by 2, so I end up with this thing, which I could multiply out. If I wanted to, I could leave the 2 out front, or I could multiply that 2 into the brackets. And if I graph that function, here it comes. It has changed the parabola. The parabola has changed, but the zeros have stayed the same. So multiplying it by 2, multiplying everything by 2, keeps the zeros the same. And you don't need a perfect sketch of those two parabolas in your note. That's not what I'm trying to show today. In fact, I think it gives it to you, does it? Oh, it's on the next page that you get them both. Yeah. So again, just to review this, you're like, okay, so you brought us in here today, Mr. Todd, to tell us that if we multiply everything by the same number, the whole parabola, the whole quadratic by the same number, the zeros will stay the same. Yes, so far that's all I've said. One sentence covers what I've done today. But is there any questions on that? Do you need more time? Let's try another. This time we'll apply a vertical compression of a factor of 1/2 and a vertical reflection in the x-axis to the original function. We said all those things were allowed. So here it comes. I'm going to multiply the whole thing by -1/2 this time. So I'm doing the vertical reflection, but I'm also compressing instead of stretching. And I get, when I multiply everything by -1/2, I get -1/2 times x squared, -1/2 times -8, which is +4, because half of 8 is 4. I know some fractions are hard, but half of 8 is not one of them. And half of 12 is 6, but it's switched to negative. If I graph that thing, here it comes. Soon. In green, do you see it? It's flipped over now. It's been compressed. It doesn't get as far from the x-axis as it was, but it does have the same zeros. And that's what today's lesson is. How do we keep the zeros the same? Multiply through by the same value. These are all called a family of functions, actually. They're all in the same family. They all have the same zeros. Do you have any questions about that? Do you need more time? Who needs more time? Do you still need more time? Good? Okay. A simple demonstration to explain what we just saw. Now I feel like I'm over-explaining. But here it comes. The function x squared minus 8x plus 12 in factored form is x minus 6, x minus 2, like that. So you can see what the zeros are. If I multiply the whole thing by a stretch factor of 2, I just get a 2 out front of the whole thing. And the zeros are still 6 and 2. Now, if your algebra is still something you're working on, you might think, oh, you didn't multiply everything by 2. You only put the 2 out front. Shouldn't everything get multiplied by 2? And the answer is no. The 2's out front everything. It's going to multiply. If I distribute it, it'll multiply by everything. That's what distribution is. So when there's distribution going on, you don't go in and put the individual 2 on everything. You can just put it out in front of the brackets and say, there. It's out in front of everything. It is going to get multiplied by everything in the brackets if I decided that I wanted to distribute it. Same with vertical compression. If I took this thing and multiplied it all by negative 1/2, the factors stay the same. I've just got a negative 1/2 out front of the whole thing. I don't know why this PowerPoint does a giant get it, but maybe it's just to encourage me as a teacher to stop and go, is it clear? It doesn't mean to get it like somehow it's so easy that you should just automatically get it. It means stop for a second and go, is it clear what's happening? If I put a number out front of these brackets, what makes them 0 stays the same. All of these functions, the zeros stay the same, even though the vertical stretch has changed and the parabola has changed how much it's stretching up and down. Do you have questions? It's supposed to be a bit of a relief lesson after another word problem lesson. We try to do a word problem lesson and then do something that's a little more easy to handle. Some examples. Find 2 quadratics that have the same zeros as this. If you understand what's going on, life is pretty easy here. Multiply this whole thing by any number you want. You can be as creative or as simple as you want. What did I do in the PowerPoint? I decided to multiply it all by negative. That was the simplest thing I could think of. If I multiply everything by negative, and so it becomes negative 2x squared minus 3x plus 10, I get the exact same parabola, just flipped over. I also chose, I forget what I typed into this PowerPoint to choose, I chose to multiply it all by the number 3. Maybe you would have gone 2 to go, let's keep this as simple as I can. But I chose to multiply it all by 3. And then, so it became 6x squared plus 9x minus 30. Those 3 parabolas will all have the same zeros. Will they look different? Yes, but they'll all have the same zeros. Now, just when you think this is the easiest lesson we've done in a while, the next question just has one little curveball in it. It's an algebraic situation that we got to address. It says, which of the following functions have the same zeros, as this one? Now, what I've got to find is functions where the whole thing's been multiplied by the same number. And what I mean by that is the constant has to be multiplied by the same number, and the coefficient out front of the distribution has to be multiplied by the same number. So let's look at the first one. If it's going to work, if this one's going to have the same zeros, it has to be the same number I multiplied by. Well, what does the number have to be? What does negative 3 get multiplied by to become positive 6? Negative 2. Does that work for the constant out here? Did negative 5 times negative 2, does that become positive 10? Yes. So negative 2 works here. And again, if you're bothered by the fact that I didn't distribute it and multiply everything there, no, I did. I will. That number is built into the distribution. If I did distribute it, it would distribute in. So I don't have to put it on each individual thing. How about this one? This one got multiplied by a negative. That became positive 3. Did the constant term get multiplied by negative? Yes, it did. So that one has the same zeros. What about this one? Oh. Did they all get multiplied by 1/4? Yes, they did all get multiplied by 1/4. Are they all? What did I miss? Do you see it? Which one did I miss? The coefficients are all right. The constants are all right, but look inside the brackets. Look how tricky they were. +2, +2, and they sunk in this little -2. This relates to something we were talking about in calculus today. You look on the chalkboard, and there's some crazy calculus there. And do you see the mess? Each individual step of this, when we did in calculus today, was not difficult. Each individual step. The difficulty of this question was how much was going on. Good luck keeping track of it all, because your brain sort of muddles over when you're looking at the algebra. The way to look at algebra is like this. You point at the -3 and go, is that the same? Yes, it's multiplied by -2. Is this the same? X, is it the same? Yes. +2, yes, the same. See, to actually individually force your brain to focus on the individual things. Because if you look at the whole thing, good luck trying to find these little things that happen. So, -3, did it get multiplied by -1? Yes. Oh, but that can't change. The one inside doesn't change. That'll change where the vertex is. That'll change zeros. So, the middle one is the one that is not. If you find that tricky, I know, that's the curveball question in today's lesson. Mr. Todd, if I was confused, could I just multiply out the brackets and be able to tell that way? Absolutely. It's the brackets that are causing the problem. If you multiplied it all out, you'd be able to see for sure which ones have the same zeros. So that would be easier. What, do you have any questions on that little messy bit question there, Nathan? Question?
Aren't all the ones in the bracket just like +2, except for the middle one?
Yeah, yes. But then we just had to check that the numbers out front were all multiplied by the same thing. Yeah, because you can't just multiply by different things. So on that first one, I had to multiply by, both those were multiplied by -2, yes. Inside brackets stay the same, yes. Second one, they were all multiplied by negative, yes. Inside brackets stay the same, no, it didn't. So that's why that one failed. Yeah. Other questions there?
So the inside bracket has to stay the same.
The inside bracket has to stay the same. Because you're like, why doesn't it multiply in? I'm like, it does multiply in. It's still sitting out there ready to multiply in. So we haven't multiplied it in yet. So the only way to multiply that term by something is just to multiply the coefficient by something.
So what do you multiply outside the brackets?
In this one, anything you want, as long as you do the same to both. See, in this one, I chose to multiply negative by both things. I multiplied the -3 by -1, and I multiplied the -5 by -1. That's all fine. You can't change what's in the bracket, though, because it hasn't been distributed. It hasn't been multiplied by things.
So what's in the bracket will never change.
Right.
Or else it doesn't
Right. Yes, or else it doesn't work. In this particular lesson, looking for zeros. Again, multiplying out a set of brackets like this is not particularly difficult. If you were worried about it at all, you could multiply out the brackets. But what's going to happen here, if I multiply out this brackets, is I'm going to get a -2x, another -2x. Here I'm going to get +2x and +4. So the signs are going to be all wrong if I was to distribute that all out. Yeah. Remember what we saw at the beginning of the lesson. We saw a lot of stuff. What do you mean? The zeros of a quadratic function are most easily identified when the function's in factored form. A quadratic function has the zeros 6 and -7. Write two possible equations. It looks impossible at first because this question asks you to do it in reverse. It's got zeros of 6 and -7. If the zeros are 6 and -7, what are the factors? -6 and +7. You're both on the trail to it. I know it's going to have -6 and +7. This might be the first time we ask you to do it in reverse. I give you the zeros, now you come up with the factors. But this question said write two possible ones, so then there's one that I multiplied out, and then I could multiply the whole thing by 2. And this sort of explains why you needed the same things in the brackets. You say, well, you can just multiply the front out by 2. No, everything gets multiplied by 2. It's just when it's in brackets, it's not distributed. So the 2 eventually does multiply by everything out front. So really, you could have answered the question right like that. You could have stopped right there and said, there, I'm done. Just put a 2 out front of the whole thing. It did say put it into standard form. A little bit of practice at multiplying out the brackets. Nathan, you had a question there, or did I answer it as I kept going? I cruised right through it today. I'm bad for that.
Mr. Todd, I'm liking the best
I was able to say Tommy Hilfiger and still say semi-formal, yeah. And a tie. which I almost never do. Weddings? No. Funerals? All right. Grade 8 parent night? Tie. I'm trying to convince people to come to St. John's? Tie. Remembrance Day? Tie. Besides that, it's such a weird construction, isn't it? Right? I'm going to wrap a piece of cloth around my neck and now I'm formal? Seems weird. Yeah, it's a weird decision. I get it. It's a whole society thing. I'm playing along. But I don't really get it. You know, I'm like, what? Yeah. It's like shiny shoes. Like, okay, your shoes are shiny. Now you're formal? Yeah. What do I know? Nothing. They're not going to ask me. Little sidetrack there. Tell me your questions. This, if you're worried about that 2 out front, this really shows off what's going on. Putting the 2 out front does multiply the 2 by everything, eventually. Questions? More time? All right. We have seen that there are an infinite number of parabolas that can be drawn through given zeros. How many points then do we need to make the parabola unique? And the answer is 3. You need 2 zeros, and then you need a third point. Now, technically, any 3 points will do, but that might be a little farther than we're going in grade 11. We'll usually give you the 2 zeros and 1 other point. And this is an interesting algebraic problem that will come up on your test. Here's the idea. There are infinitely many parabolas that go through -2 and 3. But if I give you a third point, now I know exactly which parabola it is. That parabola pins down one of the parabolas as the parabola we're talking about. So if I only give you the 2 zeros, you got open season. You can do whatever you want as far as the number out front. If I give you one other point, you need to get that. You need to figure out what that number is out front, which is a challenging algebraic problem actually. But I'll show you how to do it in the remaining 4 slides. In the remaining, how much time do I got? I got to keep an eye on the clock. 25 minutes. Oh, I'll be good. And enough time to hand things back, hopefully. Okay, the idea once more. If I give you 2 zeros, you have infinitely many parabolas. If I give you 2 zeros and 1 other point, that pins down the individual parabola. So if we have the zeros of a parabola, we just need 1 more point on the parabola to determine its equations. Challenging algebraic problem coming though. A parabola has zeros of 2 and -5 and passes through the point 3, -24. Find the equation of the parabola in standard form. I'm going to do this question in 2 parts. The first part says, let's pretend I didn't see this point over here, this 3, -24. Exact same question, but I said, make me an equation that has zeros of 2 and -5. You'd write that. You'd go, well, put anything you want out front. The first factor has to be x minus 2, and the second factor has to be x plus 5 to make those zeros. If I didn't give you this point, see, I'm still covering it up with my hand. I'm still covering up 3, -24. Then somebody says, but we want the specific point 3, -24, which looks really challenging, but it's not. They've given me an x and y to use. I can just sub that x and y in. Give that a stare down till you go, I know it's a lot of algebra there, but just give it a stare down to go, oh, you didn't really do much of anything there. All I did was take this, I'm going to write it up here. I think you should write this, what I'm writing up here. I put the 3 there, and I put the 3 there, and I put the -24 over there as the y. It's an intimidating algebraic question with a simple substitution to solve it. Because this equation, although it might look complicated, is not compared to some of the stuff you've seen in this chapter. Because what's 3 minus 2? What's 3 plus 5? 8. And only one more step to go, which is divide by the 8. So this question is either really hard or really easy, depending on how much you practice it. If you practice it, you're like, oh, this one, I like this one. Make the 2 zeros, sub it in, and I'm done. Only one problem. It looks great. I love this answer. I'll put a smiley face beside it. Everything looks wonderful. And if I put one like this on the test, I don't know. I'll do something. See, it says find the equation of the parabola. In standard form, I'll underline it, or I'll bold it, or I'll do it in little italics so that it attracts your attention. So you remember, oh, standard form. I don't know why he has to be a giant jerk about these things, but I've got to multiply that out to get it into standard form. So you distribute the brackets and multiply it all by -3. I don't put that down really quickly as if it's so easy. I just mean that's all I'm doing is multiplying out the brackets. I'm quite happy to answer questions about what I did there. I just, those steps are steps that you have seen before. As long as you knew to do it, it's not particularly algebraically scary. But I don't want to rush it. Write that down and then tell me what questions you have about that particular algebra. Well, don't sleep through this lesson. Tell me, which steps do you want to talk about? Where did the what?
Oh, never mind. I see it.
I didn't even hear the question before you already answered it.
Yeah, that's where the 10 came from.
Oh, that was just distribution. -2 times 5, -10. And I only had to do this because it said standard form. If it just asked for the equation, really I was done there. That was fine. Why would you want it in standard form? Well, because the question said, please put it in standard form. Yeah. Why would you want it in standard form? What thing have we seen this chapter that wants it in standard form? If now we wanted to do the quadratic formula, we'd want it in standard form. Someone answers that and goes, why do I need the quadratic formula if it's already in factored form? I wouldn't even want the quadratic formula. And you're right. But we do practice getting into standard form because there's more algebra coming. Yeah? It's more of a, let's practice getting in standard form just in case we need to. Other questions? More time? All right. Do up your seatbelt for this one. A parabola has zeros 3/2 and -4/5 and y-intercept -24. Again, I argue what you should do with these questions is put a box around that information and say, yes, I'll deal with that. But for now, I'm just going to deal with the 3/2 and the -4/5. And now we need somebody right with this and super clever to come up with what would the factors be if the zeros are 3/2 and -4/5. Hold on. Ben wants to answer, I think. Do you? Ben's got a chance at it. Yep. Let me just rewind. When the 0 was 2, I used x minus 2, and you didn't flinch. Maybe you should have. What did I do there? I said, okay, what set of brackets will produce 2 as an answer? Maybe you just went, oh, I'll just reverse the sign. Yeah. Then the +5, or the -5, I went x plus 5. Just reverse the sign. This is going to take a little more thinking. If I don't, unless I want to deal with fractions, which I could do. Oop, almost gave it away there, Ben. Okay, if I'm going to produce 3/2, what's going to be in the brackets? Could definitely do that. It definitely works to do it with the fractions. You just will have a lot of fraction multiplying out to do. You can make your life a little easier by coming up with a slightly more clever factor. 1.5, you also can do it in decimals, but the decimals will go a little nuts because of the, halves and fifths. Halves and fifths, decimals wouldn't be too bad. If there was thirds or sevenths here, things are going to completely fall apart. So we need another level of cleverness to come up with what factor would produce a 0 of 3 halves. Fife. She's all over it, folks. Just give that a stare down for a minute and see where she got it from. 2x minus 3 will produce 3 halves and avoid the fraction problem. If you're like, oh, I like fractions, it's fine. I'm like, okay, well, you're rare. Most people don't just walk into fractions. Even I don't just trudge into fractions unless I have to. Once I'm stuck with fractions, yes, I confidently handle them. But this question does not need fractions. 2x minus 3 produces 3 halves. And 5x plus 4 produces negative 4/5. Let me just check that. 2x minus 3 equals 0. When does that happen? I'd love to know, though, Fife. How did you know? How did you decide with the 2 and the 3? Did you go over here and do some thinking like this? Or you did. You went over here and sort of thought like that. So she went through this work to go, where does the 2 and the 3 go? So that's okay to do that, to go over and go, is it 3x minus 2 or is it 2x minus 3? And you try one of them like, oh, there it is, 2x minus 3. The rest of it is just like the other question. Now I can use the y-intercept of negative 24 and sub in 0 for the x's. Let me draw these arrows to try to help you. And negative 24 for the y, because it's the y-intercept. So the x value is 0. And this looks difficult, but it's not. 2 times 0 minus 3 is negative 3. 5 times 0 plus 4 is 4. Multiply those together and solve for the a. I did that quickly again, not to rush the lesson, really. Just to go, okay, well that part, once I'm that far, solving for a isn't going to be the biggest challenge ever. And that would be great. Except for one thing, and I'll let you catch up with copying and see if you can find the one thing that this question asks for. Standard form. So cruel. In the middle of all those other steps, what level of cruelty is it to then make someone find it in standard form? Wow. Multiply out the brackets, collect like terms, and multiply it all by 2.
Copy down the note, Nathan. You don't have a phone. Just copy down the note.
I'm locked. I know I'm doing this. I'm locked. What's your phone?
I actually hope all 3 of you go to the same school after high school. Not to get rid of you, but I'd love to hear the stories from first year, how that all goes.
We got JK together.
Hmm?
We got JK together. The 3 of us. We got grade 9 together.
One more step.
Oh yeah.
I'll get a room together at Western, or like a rent a floor or whatever, or rent a. Reese, don't go. Wherever they're going, you're going somewhere else. Promise me. Got to draw a line somewhere. Please tell me your questions. I'm here to help. What questions do you have about this algebra? More time? Mr. Todd, that one's pretty bad. That would be a great place to stop the lesson. Do you have a worse one?
Mr. Todd, this
Yeah.
is brutal.
Yeah. I got a worse one. It's really bad.
Damn, he said talk to me to get over 70.
What's happening?
I'm being penalized for my grades.
Oh,
It's because he's always got his phone, right, Mr. Todd?
I have no idea.
You see him.
Something's going on.
He's not even on the right page of the note.
I flipped to the next one because I finished that.
That's the previous one.
Just for fun, if you've got an iPhone right now, open it up and look at your screen time for yesterday. It's an eye opener. It's an eye opener.
I've been having this.
Let's just give it some numbers, shall we? If your screen time's over an hour, just think about that. That's an extra hour you could have had for other stuff. Now, sorry, take a look at music. If you're playing music and it counts that, you can subtract the music. If it's over 3 hours, it might be time to examine your life. Really. I don't mean like that in an adult teacher type way. I mean this is just a human to human and say, 3 hours on your phone? Just think what you could do with your life with 3 hours. 6 hours and 30 minutes? It might be time to put yourself into rehab. Okay, subtract music though. Like if for 2 hours you're listening to music,
I don't listen to music.
Wednesday, I've already been on my phone 4.5 hours today.
it's only 12.
That was November the 1st.
Oh, my daily average is 10 hours. But that's like
10 hours.
Oh wait, it's
Day
double
by day,
track.
right? My day by day.
Mr. Todd, you know I'm not on my phone that much.
Counted.
Oh no.
It said there's 0 minutes to 1 hour for today.
All right, take a look at this one just for fun. Just for some math fun. Take a look at these two zeros.
10 hours on Sunday.
The zeros are 1 plus root 5 and 1 minus root 5. When I put it in, I just changed the sign of both of those. Okay. Not bad.
On Saturday, it was 12 hours and 20 minutes.
I know.
Yeah, but like, how are you even awake?
It's possible we need to get some, you know how they have Alcoholics Anonymous and you go to a meeting and you admit you have a problem. It's possible all of you need to go to a meeting and go, my name is Mr. Todd and I have a problem. I was on my phone for 8 hours yesterday. You know, like, again, you can subtract music and you can subtract books, but you can't subtract Candy Crush and Instagram. Reading. Yes, reading a book, like iBooks. You know, like I was reading my book. Yeah.
I drove Keen on the Monday.
Sorry, I got to get back focused here. I'm going to run out of time here. Look at
Lock in.
sub in the 2 and 5,
Carter.
and then go, I don't have time for this. This is going to take forever to distribute this out.
Calculator.
Well, yeah, if you're on your phone for 8 hours, you probably don't have time for this. Or whatever your number is. He asked a great question, actually. I won't answer the teacher way. The teacher way to answer that would be, well, you still have to study it. You know, the reason I put questions like this in the homework is if you can make this one work, then the one I put on the test will seem easy. Yes? It reminds me of I was watching a baseball team practice last night, and they did, during the practice, in between other drills, they did 100 push-ups. Now, I've never gone to a baseball game and seen any baseball player do push-ups. You never see someone hit a double into left field, and then they're doing push-ups at first base. It never happens. So you know the answer, but let's just say it out loud. So why do we do push-ups if we're not going to do the game?
Ben, this is your sport. You should know.
If they hit a double, why'd they be at first base?
That's exactly what I just said. It never happens, right? So why are they doing push-ups at practice if they're not going to be in the game? You know the answer. You don't want to say it. It makes you stronger. That's what questions like this are for. It makes me algebraically stronger. Then whatever does happen, I'm ready for it. Yeah? Well, it's bad. I won't lie. This triple distribution looks bad, but then when I combine like terms, now it's just a double distribution. Hold on. You might recognize this 1 minus root 5, 1 plus root 5 from somewhere.
Oh, yeah.
And something amazing happens when I multiply it out. I get 1 plus root 5 minus root 25. Look at this. See, there was a little conjugate lesson in this. Those two roots were conjugates of each other. And when you see conjugates, you can take a little deep breath and go, this won't be as bad as it looks. If it was 1 plus root 5 and 3 minus root 7, it's going to be a disaster. But those were conjugates. And if they're conjugates, life's going to work out not too bad. A conjugate is a binomial with a square root in it, but the sign in the middle has changed. Always multiplies out nicely. Well, nicely. It's still going to have a fraction.
Where did root 25 come from? Oh, yeah, I see it.
Whoop, whoop, whoop. Did it say in standard form? Yeah, just to torture even more. Would I put one with multiplying out square roots with conjugates and then, after it's all done, put it in standard form? No. But maybe I'd put one where you have to put it in standard form. And if you've done this question, you're ready for it. Maybe I'd put one that had some kind of square root in it. But if you've done this question, you're ready for it. You see? So no, the answer to your question is no. I'd have to be angry with a class to do that. And I've done it in calculus before when I've got angry. Said, oh, nobody's doing your homework? All right then. If you're not doing it, there's no sense me being nice either. There you go. All right, so. No, the sign last year was the uniform thing got out of hand. So I hung up a sign that said, every time I have to ask someone to take off their illegal sweater, I'm going to put a tough question on the test. And I know a lot of tough questions. Yeah. I'll hang it back up. There's been some sweater problems in here, but I know 11U is enough of a challenge. I've been letting the sweaters go. I'll get to them. Don't worry. You won't leave here thinking sweaters are okay, but I think I'm teaching the toughest course in the school. Not the toughest course in the school, the toughest jump in the school. This is the toughest adjustment to make. So sweaters I've been living with just a little bit. Especially roots ones. Hi there. Would you like a copy of the note? A blank copy of the note. Well, it said standard form, so here's all the fun algebra to get it into standard form. Those of you whose marks are pretty high and you're trying to make them higher, these are good practice to be ready for whatever could show up on the test. Okay? Those of you who are like, listen, I'm just hanging on here, definitely do the ones that have fractions, but maybe don't get bent into shape with the square root ones. I wanted you to see it, and those of you who are in AP and considering taking advanced functions next semester, hey, take a shot at it. You know, I think some of you are continue on with me. I looked at the class list at some point, so I saw some people that were just, February 1st, we just keep right on going. Yeah? And this is good exposure for some of the things we might look at next semester. Is that the last slide?
Yep.
So I'll stop the video, but I'll leave that on there. And then I'll start handing stuff back with 4 minutes to go. Don't panic, it's coming back. It's coming back, there it is.